Hi guys, I'm on page 96 and I kind of started this problem. I was having a little bit of issue with the video, so let me just review. The mass of Earth is 5.9 times 10 to the 24th kilograms. The mass of Pluto is this number, which is 1.3 times 10 to the 22nd kilograms. Compared to Pluto, how much greater is Earth's mass than Pluto? So we can do subtraction, right? It's just really big numbers. So what we're subtracting is 5.9 times 10 to the 24th power subtracted, and we're subtracting that with 1.3 times 10 to the 22nd. And then I started to subtract these and I realized, oh no, I cannot do that. And that's when something happened with the video, so we'll erase that. So I cannot just subtract those two because look, the bases are not the same. And so what I instead need to do is I need to make the bases the same. So if I say that 5.9 times 10 to the 24th power is the same thing as 5.9 times 10 to the second power times 10 to the 22nd power minus 1.3 times 10 to the 22nd power. Okay, and that's Pluto's mass over there. So then if I do that, then I'm going to get, right, this is 5.9 times 10 to the second, so I could just move the decimal twice and get 590 minus 1.3, and then we could say that all of that times 10 to the 22nd. So the bases are the same, so now I could combine them. Okay, and now 590 minus 1.3 is 588.7 times 10 to the 22nd power. This is not scientific notation yet. I would have to move the decimal twice to the left, which means that that is going to be equal to 5.887 times 10 to the 24th power. Okay, and that is, so the mass of the Earth, I'm trying to find a way to not have to write again. So the mass of Earth is 5.887 times 10 to the 24th kilograms greater than the mass of Pluto. Okay. Now exercise 4 is using the information in exercise 2 and 3. Find the combined mass of the Moon, Earth, and Pluto. So that's all. So the Moon, Earth, and Pluto. So if we take it back to exercise 2, we had, let's see, what was our answer? So I'm going to write this: Moon, Earth, Pluto. So we know these two are here, right? Pluto is here, 10 to the 22nd. Earth is here, which is 5.9 times 10 to the 24th. And the Moon, sorry, is the 7.3 times 10 to the 22nd. Okay, and really I am adding all those three numbers to get the total. So what I can do, this is already 10 to the 22nd, 10 to the second. This needs to be 10 to the 22nd. So I could add those two. If I say 7.3 times 10 to the 22nd plus 1.3 times 10 to the 22nd plus that 5.9 times 10 to the 24th outside of it. So this is going to equal 7.3 plus 1.3, which is 8.6 times 10 to the 22nd, plus out there 5.9 times 10 to the 24th, which is equal to, if I did what I did up here, right, I'm going to get that 590 times 10 to the 22nd, right? So I'm just going to use that here to say that 8.6 plus 590 and then times 10 to the 22nd. So I'm kind of just using that up there, so I don't have to rewrite it. And then we could combine those two numbers and we get 598 times 0.6 times 10 to the 22nd. And to rewrite that in scientific notation, very similar to that, is going to be 5.986 times 10 to the 24th is the combined mass of the Moon, Earth, and Pluto. Okay, and that would be kilograms, sorry. All right, exercise 5. Whoopsie. Exercise 5, that's my calculator over here, is how many combined Moon, Earth, Pluto masses, which is the answer to exercise 4. So this answer are needed to equal the mass of the Sun. So we took the mass of the Sun and we divided by the combined masses. Then we should be able to find how many are needed to equal the mass of the Sun. Okay, so let's do that. We have mass of the Sun, which was 1.8, right? Something, why can't I find it? Mass of the Sun, it's not on this page, right? It's over here. Oh, mass of the Sun, 1.898 times 10 to the 30th. And the combined masses is here. And I understand this would be a very hard lesson to do if you were to get any of the problems wrong, because it kind of builds on each other. So it's good that you're reviewing it with video. Okay, so if I divide these two, I'm gonna get, it's just kind of looks like I could divide those two right there, and I get 0.3170, it goes on and on. Times 10 to the 30 minus 24, which is 10 to the 6th. And so let's round that to approximately 0.32 times 10 to the 6th. And then obviously I want to make that in scientific notation. So that's also equal to, if we say 0.32 times 10 to the 5th. See, we're kind of breaking that up. And that way this could become 3.2 times 10 to the 5th. So it would take 3.2 times 10 to the 5th combined masses of Earth, Pluto, Moon to equal the Sun, the mass of the Sun. All right, okay, you're ready to go do your assessments for lesson 10. Bye.